Welcome to the next chapter in this course, Module Cross-Cutting Concerns. Before we dive into writing the code for this chapter, I think it's worthwhile to spend some time and discuss what should our motivation be to solve cross-cutting concerns in any kind of application and especially inside of a modular monolith. I also want to discuss how you can approach sharing the code between modules and what could be the implications and some trade-offs that you could be making when doing this. And then I'm going to discuss the cross-cutting concerns that we will be implementing as part of this chapter. So the first point I want to discuss is our motivation for solving cross-cutting concerns. We said that modules should be self-contained, meaning that they should be able to provide the required functionality to fulfill the necessary business requirements, and the module should be able to do this by executing its business logic while working on the data that this module owns. If we take this principle to the extreme, we risk ending up with a lot of duplicated code across our modules, implementing the various cross-cutting concerns that might be necessary. And while I certainly don't shy away from duplicating some code across my modules because I want to make each implementation specific to that module, there is definitely a lot of value in solving some cross-cutting concerns separately from our module logic so that all of the modules can use the same functionality. And there is another benefit to extracting our cross-cutting concerns into some sort of common or shared library. And this benefit is improved speed when it comes to introducing new modules into the system. So whenever I need to add another module, I already have my cross-cutting concerns solved, so I can just plug them into the module and focus on solving the business requirements that the new module should fulfill. Here's an example of what this might look like with the 4 modules that we will be implementing inside of our system. We're going to have the users, events, ticketing, and attendance modules, and you can notice that all of them are implementing the clean architecture. However, all of our modules are referencing the cross-cutting concerns component that could be solving things like dependency injection, configuration for each module, exception handling, validation, and so on. Another problem that we will need to solve is how we are going to use dependency injection inside of our modules. Inside of ASP.NET Core, the dependency injection implementation only has one composition root, which means that all of our services are shared inside of the same application, and this introduces a lot of constraints when it comes to reusing generic types across our modules. Now, there are a few ways how I solve this, and I'm going to show you how to do it, but probably the best solution would be to somehow implement multiple composition roots for each of our modules. Now, there is a library that offers something like this, and it's called Autofac. However, I don't want you to have to learn a completely new dependency injection library in order to implement something like this. So just keep in mind that the dependency injection implementation in ASP.NET Core has some limitations, and we will be working around those limitations to the best of our ability. Another question is, what should you be sharing between your modules? Well, these would be things like generic abstractions, for example, an entity type in your domain, maybe the result object if we want to use it across our applications. This would definitely be something that falls under a cross-cutting concern. But when it comes to anything that is specific to the module, and let's for example take the database context, we want to keep it inside of the module. And ideally, we want to hide the existence of this component from the other modules entirely. So that means we don't want to expose our database context, we don't want to expose our API endpoints, our use cases, or anything similar. And because we want to achieve this, duplicating code is sometimes necessary. You're going to see this in one of the future lessons when we are implementing the outbox and inbox pattern as a good example of this. If you aren't familiar with these patterns, don't worry at all. I'm going to explain them in depth. But why I'm using this example is because we're going to need a background job that will be processing our outbox. And the implementation of this background job is very generic. It's just going to fetch some records from the database, do some processing, and then persist these records into the database. However, if we wanted to make this a generic component, we definitely could, and we could end up sharing it between our modules. However, I found that this approach leads to some limitations, which is why I decided to have a duplicated implementation inside of each module. Of course, we're going to discuss this in more depth when the time comes to implement this feature. Another aspect I wanted to discuss is how you can approach sharing code in the long run, and because we are starting out with a modular monolith application, we don't really need to use NuGet packages. We can just use the projects that are all inside of a single repository and reference the required cross-cutting concerns that are going to be in some common or shared projects. But when the time comes that we need to extract some services outside of the monolith, NuGet packages are very valuable. A good candidate for sharing code using NuGet packages is message contracts if you are using messaging for communication between your modules. Now let me introduce the cross-cutting concerns that we will be solving as part of this chapter, and we're going to start with dependency injection. We're going to follow this up by solving configuration as a cross-cutting concern for our modules. Then we are going to add structured logging, followed by exception handling. Of course, we are going to need something to solve validation for our use cases. Caching is another cross-cutting concern that could be valuable for us to improve performance. Health checks are another good example of a cross-cutting concern that we would probably want to solve separately from the module logic. And this isn't a complete list of all of the cross-cutting concerns that we could solve. These are just some of the most important ones. The other ones, for example, metrics and tracing using OpenTelemetry, we're going to handle in a separate lesson that's going to be dedicated to just that. And now let's head over to our next lesson, solving dependency injection as a cross-cutting concern for our modules.